Hey guys, welcome back. So in this lesson we'll take a look at our three fitness values, which is the view quality, the square meters of the individual footprints, and the last one is the distance between the buildings. And I'm going to continue with the previous definition we left off. And again, I'm going to start on a new line. So I'm going to continue with our view rays. So let me insert a curve component, connect it, and drag it to a new line. More or less here. Let's set the wire again to hidden. So those are our view rays. Now we need to add all these line lengths together, and we're going to use a mass addition component to do this. But before that, we need to do some branch organization first, some tree management operation. And we're going to use the path mapper for that. I mean, there are various ways to do this, but I prefer to use the path mapper. I think it's the most easy. So let's simplify this curve component because it has a boatload of zeros. So now it only has a depth of 3 branches, which is cool. And let's set the create null mapping. So basically we want to shift the B and C branch so they get combined with the A branch. So we can basically just remove the B and C from the target. So now we have all the view rays per footprint or per building mass. And we need to get the length of those lines, and we're going to use the length component or line length component. And if I use a panel, or better a param viewer, I only have 4 branches with a certain amount of lengths in them. And to add them all together, we can use a mass addition component. It goes through a list of numbers and it adds them all together to a final result. And now if I insert a panel to see the result, the R, which is the final result, you see that we have 4 numbers, 4 big numbers, and those 4 numbers represent the total line length of the view rays. So as you can imagine, we want to make this number as high as possible, because the higher this number means the better the view quality, as we established in the previous lesson, like a simplification to determine the quality of the views. So that's 1. And let me rename this so we know what it is. So this is the view quality. Fitness value. Now let's go to the next input for Galapagos, which is the areas. And we already have those. We established them all the way in the beginning, which are those, from the 4 footprints. So let's insert a area component. And let's drag it down to here more or less. Set the wire to hidden. And let's rename this to area footprint. Fitness value. We also put a panel to it. So we need to make sure that these 4 values are within a certain tolerance of about 1,000 square meters, or a value we specify here in the beginning. I mean, right now we have 1,000. So the third one, like I mentioned in the previous lesson, that's going to be the distance or the minimal distance between the buildings. And that's for accessibility and sunlight on the facades. We have to write a small definition to acquire those distances. And let me go to the top view. And let me turn off some components so we can specify them a little bit more clearly. So those are our 4 footprints. Let me link them again to this curve using the original curve. Let's set the wire to hidden. Nice. So we're going to use a component that is located under the Curve tab. It's under Analysis, and it's called Curve Proximity. And this is a very nice component because it finds the closest distance between 2 curves. So in the A and the B goes the 2 curves, and the output would be the A and B point where the closest distance between the curve occurs. So we need to do some list management to organize our 4 curves in a certain way that the component can find the proximity between them in a logical way. And we're going to use a component that's located under the Sets tab, under List, and it's called Cross Reference. And this is a very helpful component. I'm not going to go over the specifics of this component. If you would like to know more specifics about this component, I advise you to watch the Grasshopper 102 course. So let's collect our curve to both the A and the B input. And we need to set it to diagonal, which means that they get cross-checked against the other curves, but not against itself. And that's exactly what we need. And we need to, of course, flatten this list, because else it doesn't work, because the component cannot work with only one item in the list. So now we have 12 and 12 outputs. And in a second it will become clear what this means, what this component exactly did. But for now we can connect the A to the A and the B to the B. And some points now occurred, which is really nice. So the next component we need to insert, because we need to reorganize these 12 output points a little bit better, and also the distances, which is the partition list. As you can imagine, every footprint has 3 points on the other 3 footprints, etc. So the next footprint also has 3 points because it finds the closest distance between its 3 neighboring footprints. So the length of the partition needs to be 3. And we can get this length by getting the list length of our input curves. And with a simple expression, we can get the number 3 if we do x minus 1, because there are 4 input curves. We could also do this manually, but if we change the number of polylines we insert in the beginning, this will automatically be updated and still works, so that's nice. So now we have 4 branches with 3 points. And let me show you what happened, because I can connect a line component between the A and the B. And now we have a set of lines. And if I simplify this output, and I use a tree branch just to select one branch, you see that I have selected the first footprint. Those are the 3 lines that are the closest connection points between the other 3 buildings, and so forth. So this is the first one, this is the second one, the third one, and the fourth one, etc. So it's really nice. It's like a really short and fast way to get the distances between the neighboring footprints. The only thing is that we don't need all 3. We just need the most critical distance. So we can do this by using a sort list component. This output, those are the distances. So we only need basically this value. So this value goes in the K, and we can sort the points simultaneously. So now the distances are sorted, and we only need the first item. which we can retrieve the simple list item component. So basically we only need the k value, but just to show you what I did, to make it more clear, we can also connect the list item to the a and the b output. And again, connect the line component between them. So now I only have the shortest distance basically between the footprints. So let me turn off the components. And like before, just to do a quick check, let me just draw some rectangles on the Rhino canvas so we can check if this part of the definition actually does what it's supposed to do. So let me insert some random curves. So this one goes to here and goes into these two. We turn off the footprints. Also here. And also here. Nice, so supposedly we should only get the shortest distance. And as you can see, that works nicely. Because if I move this one a little bit more closer to this one, you see that now a connection between these two is established. And sometimes you only see two lines, which means that for this outline, it means that also this building is the closest one. Nice. So we can delete these 4 curves and let's connect our footprints again. So let's move this a little bit down. Okay, so nice. So these are our fitness values. And this is the fitness value from the 4 distances between the buildings. So that's nice, or the shortest distance. So let me also rename this to be shortest distance fitness value, for lack of a better name. And let's set it to its text so we can read it. Okay, perfect. So now we have our 3 fitness values. And in the next lesson, we're going to take a look into how to normalize the range of these values. Because as you can see, they vary a lot in their magnitude. The view quality values, they go into the 100,000s. And the area will more or less stay the same around a value of 1,000. But the distances, they're way lower. They're around 20 or lower even. So we need to find a way how to normalize the ranges so they all have the same impact in Galapagos. And that's exactly what we're going to do in the next lesson. So thank you for watching and I'll see you in the next lesson.